In this video, I'll discuss best practices for exception handling. When working with any API, it's necessary to determine what exceptions are thrown by the object's constructors or methods. The example here is for the file class. File has a createNewFile method that can throw an IO exception or a security exception. Security exception is a runtime exception, so security exception is unchecked, but IO exception is a checked exception. These two screenshots show a simple test checked exception method. In the first example, the file object is created using the constructor. Notice that even though the constructor can throw a null pointer exception if the constructor argument is null, you aren't forced to catch this exception. However, in the second example, createNewFile can throw an IO exception, and NetBeans shows that you must deal with this. Note that file is introduced here only to illustrate an IO exception. As you learn more about the file class and a new set of classes in the package java.nio, you'll discover more elegant ways to work with files. This example is handling the possible raised exception by throwing the exception from the test checked exception method called on line 5 and catching the exception in the caller method. The catch method on line 6 catches the exception because the path to the text file isn't correctly formatted. System.out.println on line 7 calls the toString method of the exception and will result in a java.io.io exception, explaining that the file name, directory name, or volume label syntax is incorrect. When considering best practices for exception handling, you should catch the actual exception thrown, not the superclass type. You should examine the exception to find out the exact problem so you can recover cleanly. You should also keep in mind that you don't need to catch every exception. Programming mistakes shouldn't be handled. They need to be fixed. And it helps to ask yourself, does this exception represent behavior I want the program to recover from? In other words, the bad behavior can tip you off to inefficiencies or errors in programming methodology, so they actually help to improve your code by forcing you to consider them. This code illustrates two poor programming practices. The catch clause catches an exception type rather than the IO exception type, the expected exception from calling the createFile method. The catch clause doesn't analyze the exception object and instead simply assumes that the expected exception has been thrown from the file object. A major drawback of this careless programming style is shown by the fact that the code prints the following message to the console: there is a problem creating the file. This suggests that the file hasn't been created, and indeed any further code in the catch block will run, but what is actually happening in the code? Putting in a few system.out.println calls in the createFile method may help clarify what's happening here. The output that's created on lines 12 and 14 provides a true or false result, letting you know if the file's been created. And the exception you'll receive is an array index out of bounds exception that's being thrown by the final line of code in createFile. So it's obvious that the array assignment can throw an exception, but it may not be so obvious. In this case, the createNewFile method of file actually throws another exception, a security exception. Because it's an unchecked exception, it's thrown automatically. So the bottom line, if you check for the specific exception in the catch clause, you remove the danger of guessing what the problem is.